All right, good morning, everybody. How are you doing? This super fantastic Monday. I know, Mondays are the worst, right? But we're going to make it better, I promise. But before we get with the better making process, a few announcements to cover because we're getting towards the end of the year. So some reminders here. Due to the holiday, all classes will be online next week. That includes next Wednesday, but Wednesday will be a half day. So all the classes have been shortened to only 30 minutes. If you look at our schedule then for this class, I'm turning that into a work day. So you will have that day all the same assignments. You'll still have Mondays and Tuesdays classwork. You'll still have that week's homework. You'll still have the SAT practice to work on. So I'm just going to say dedicate that day to getting those done, and then you don't have to worry about any of that the rest of the week, okay? I myself will be extra remote on that day in particular, coming at you live from my folks' house. So it can be real simple. Check into Zoom. Hey, you're here. Hey, you're working on stuff. And then just go do it, okay? That's as strict as I'm going to be on that. Now, the final exam itself, though the exam times for each class have been posted on the master schedule, so that is in there. Have a look at it already. Start planning that out now, okay? So it won't come as a surprise. Set that time aside, okay? The week before the finals, then, is entirely review in this class. So we're going to spend our class time working on review questions, and then at the end of that week, you will take a review quest. And I say it's a quest because it's a quiz worth test points. So I kind of portmanteaued those together. Okay? Because it's a quiz that means you get to retake it as many times as you need to get the score that you want. I know not everybody has been taking advantage of that on the regular quizzes this year. So please, please, please take advantage of that on this quiz test. Okay? It goes in as test points, but you get to redo it right away. There's no reason not to have 100%. There's no reason this should not significantly raise your grade. Okay? Hand it to you on a silver platter. Please don't throw it on the ground. And then, of course, on exam week, we'll have standard, more final exam. I'll have more details on that when we get there sooner. Okay, any questions on the announcements? No? All right, then let's go forth with today's super awesome topic, which is the Pythagorean Theorem. Yay! Probably like the most famous, the most well-known math theorem out there. Certainly the best known geometry theorem. You've probably already heard it before. Can anyone fill in the blank for me here? For any right triangle, okay? Emphasis on right. This only applies to right triangles. If you call the sides A, B, and C, Pythagorean theorem gives us equation what? Anyone know?
Is it a squared plus b squared equals c squared?
Yes, very good. A squared plus b squared equals c squared. In fact, this is such a well-known theorem that it's even in the Lego Batman movie, okay? That's how good it is. So, oh, I should have queued up that clip. Maybe once you get working, I'll see if I can pull that up. Anyways, right? So long as we recognize that C, being the odd one out, it's literally on the other side of the other two, is the hypotenuse That's a strange word for you. Just remember, it is the longest side. It is the one opposite the 90-degree angle. So let's run a quick example here. Give me two numbers for A and B. Type them in the chat if you have to. Give me a number.
5 and 2.
5 and 2. Awesome, 5 and 2. Okay, so let's check. If this had side length 2 inches, centimeters, whatever units, right? And this had length 5, what's the length of C? We'll just put that in here. So 2 squared plus 5 squared. Oh, I did B squared plus A squared. That doesn't matter. You're just adding, okay? The order doesn't make a difference. Equals what? 2 squared is 4. 5 squared is 25. So that's 29 equals our C squared. So our final step, take the square root of both sides to undo that squaring. And then you have C is equal to, it's the square root of 29. That would be our exact answer, and you'd have to get out your calculator to get some decimal approximation for that one. Let's say 29 square root, boom, 5.385, okay? There we go. Okay, a little more than 5, less than 6. That's it. That's the process. That's the Pythagorean theorem. It lets us find that third side of any triangle. So now, of course, if you had the long side and you wanted to find one of the short sides, you'd move one of these over here and you'd subtract and then square root, right? Very easy to use. Now, a couple more points on this theorem because it's so fantastically awesome. Even though it's named after a Greek guy, the ancient Egyptians actually had knowledge of this. In fact, they used it kind of the opposite way to form a right angle. Remember those great big pyramids, okay? They are perfectly square. How did they measure and make sure they were perfectly square? They didn't have all the same tools. They had rope. I'll let you think about this one for a little bit. How could you possibly form a right angle with a piece of rope? It doesn't, like, you can't bend it. It's soft and squiggly. You can pull it taut to make one line. But if you tie your rope into a loop, and then you have someone stand here and pull on this side, and someone stand here and pull on that side, and someone stand here and pull on that side, you'll end up with a triangle out of your rope, right? And how can we make sure that this triangle is a right triangle and thus contains a right angle? What they would do is they would actually tie a series of knots in here so that it had a specific count of knots evenly spaced along the triangle. And then 1, 2. Such that the segments between the knots could be counted and they would conform to the Pythagorean theorem. So if you look here, I should have 1, 2, 3 segments between, 1, 2, 3, 4 segments between, and 1, 2, 3, 4, 5 segments between. Double check for yourself that 3 squared plus 4 squared equals 5 squared. It works, doesn't it? And so if you have people pulling on the rope, again, you got to keep this taut, right? So we'll just kind of give it a pull right there. They will know that this angle must be a 90-degree angle, and thus they can hold that over their project and line up your blocks or your bricks right? Your cut stone to be that with that rope nearby. That's pretty fantastic. In fact, we could list the converse of the Pythagorean theorem, right? Not only can we say, if the triangle is a right triangle, then a squared plus b squared equals c squared, but also converse, if a squared plus b squared equals c squared, then triangle ABC is a right triangle. Right? And I simply call it ABC because the sides were named A, B, and C. It's fairly typical to name the sides after the angle across them. Anyways, right? If Pythagorean theorem holds true, then it must be a right triangle. I guess we could generalize it, say the triangle. That'd be fine. The triangle is a right triangle. Which means you can use that as a test to be sure, hey, is this triangle here, is that a right triangle? It looks like I don't have my protractor with me. Shoot, what can I do? Measure the three sides, check if the calculation works out. Fairly nifty. All right, any questions there so far? No? Then I have one more point to make on this topic, and that is the Pythagorean triples. You may have noticed the 2 and 5 gave us a C of 5.38, right? We didn't get a nice integer number in the end. We got some strange square root with some funky decimal approximation. That's fine. That happens. It's the most common result, but if you want to get a perfect integer answer every time, we call those numbers that work out that way Pythagorean triples. 3, 4, 5 being the most common. 3 squared plus 4 squared equals 5 squared. It's pretty cool. And in fact, these are so common that I highly, highly recommend, cannot highly recommend enough, that you memorize these 4 sets of Pythagorean triples. There are many more. You can look them up online, all kinds of great triples of integers there that work out. People have checked. Okay? But these are the 4 most common, and thus they are the most common triangles you will find on the SAT. Okay? Very, very frequently, most triangles on the SAT are going to be right triangles, and most of the time they are going to be measurements in Pythagorean triples. In this descending order, 3, 4, 5, the most common, 5, 12, 13 would be the next most, the 7, 24, 25. Hey, those numbers sound familiar. 7, 24, 25. Hang on a minute. 7, 24, 25. 7, 24, 25. Aha! Here it is. I told you we would be coming back to this. Right? So if you were stumped for how to find the height of my cone, I only have the slant height. Notice that this guy right here is a right triangle. They have it marked as such right there. So I can use half the diameter gives me the length of this leg of the triangle, 7. I know the hypotenuse, 25, because it's the side across from the right angle. And if you know your Pythagorean triples, you don't even have to do the calculations. You recognize, hey, those are 2 very special numbers that go together. The other one must be 24. 7, 24, 25, Pythagorean triple. Look at that. See? Super handy. And then you don't even have to run the numbers. So memorize, memorize, memorize these guys. It will save you time and trouble. And recognize that you could have multiples. The SAT, in addition to loving their 3, 4, 5 triangle, I would say, if anything more than the 3, 4, 5, they love doing the 6, 8, 10. Because it turns out, if you double all the numbers, you're just scaling up the triangle, the Pythagorean theorem still holds true. It's still a Pythagorean triple. 6, 8, 10. You could go 9, 12, 15, right? 3 times each number. Any multiple, so long as you multiply all 3 numbers by the same thing, it will still be a Pythagorean triple. All right. Any final questions there? No? All right. Then I leave you with the rest of today's worksheet exercises based on the Pythagorean theorem. Okay, do notice we're dealing with a circle here, the coordinates of C. You've got the hypotenuse there, okay? And you know the coordinates of these 2 points. You can find the coordinates of C based on, well, it has to match the y of A and the x of B, and that'll give you, you can figure out the lengths here, just a little subtraction, then Pythagorean theorem to find that radius there. A little more involved, very doable. All right. Perhaps the most difficult one, 10 even isn't actually that bad. Usually by the 10, you get the worst of it. It's not even that bad there. Number 8, do keep in mind watch your congruence marks here. Okay, for each stage, you're still going back to the right triangle. So don't get thrown off by this little triangle in here. Realize once you have this length, you know this, and now I can find this larger right triangle. And then it's still right triangle, right triangle, right triangle, all the way. Okay? That's about all the hints I can give you for now. If you run into anything else, please feel free to ask away. I'll be glad to help you out. But otherwise, I'm going to leave you to do the rest.